Hello students, today I am here to present to you the solution of our theorem that was asked in Facebook. One of my friend had sent it. He had messaged me. So today I will try to make you clear about the solution of this our theorem. So before starting the solution, first of all I will like to recall you. So what are the major tools that we are going to use here to solve this our theorem? So here you can see here we are asked to prove the areas are equal. So here we need to recall about the theorems that are related to the areas. So here we have read first of all, parallelograms standing on same base and between same parallels are equal in area. So this was the first theorem that we have read. So you can see here in the figure. So there are two parallelograms, PQRS and QRUT, or you can say TQRU. So they both lie on same base QR and they are between same parallels QR and PU. So here you can say area of parallelogram PQRS is equal to area of TQRU. So this was the first property that you have read. Now the next one, the area of triangle is half the area of parallelogram standing on same base and between same parallel. This was the second property. The third one, triangles standing on same base and between same parallels are equal in area. Similarly, the diagonals of parallelogram bisect it in two equal halves, and lastly the median of triangle bisects it in two equal halves. So these are the five major properties that we are going to use here. So be focused in these five properties because we are asked to prove the area of triangle ABC is equal to 8 times the area of triangle EFG. So you need to be focused on these five properties. So let me show you the figure. So here we can see here D is the midpoint of BC. It means 8 is the median here. So since 8 is the median, so first of all we need to see the property about median. So if you look among these five properties, the last one, the median of triangle bisects in two equal halves. So this is the last one, that property that we are going to use here. So here we can say triangle ABC is equal to 2 times triangle ABD. So you can see here, so this 8 is the median and this right triangle, twice of this right triangle is equal to the whole triangle ABC. So now look here again in this right triangle here you can see is the midpoint of AD. So again here B becomes the median, so you can use the property of median. So we can say this triangle ABD is twice of triangle BED. So now here we are about to solve here. So in order to solve, first of all here F is also the midpoint. So if we join here D and F, then again we can get another median. So let's join it. So here you can see here, so DF is the median, and here again triangle BED equal to 2 times triangle EFD. So now if you become able to show that these two triangles DEF and ZFE are equal in area, then you will get the solution. So for that, so you can see here they are on the same base. So now if you join here DG and you become able to show that these two lines are parallel to each other, then obviously you will get the solution. So here you can see this is also the midpoint and this is also midpoint, and in class 9 we have already read that the line segment joining the midpoints of any two sides of triangle is parallel to third side. So here you can easily see these two lines are parallel to each other. It means those two triangles will be equal in area. So you can see here if EF is parallel to DZ, then you can say area of triangle EFG is equal to the area of triangle EFD. So in this way we can prove it. So let it be proved here. So first of all, let's write the given conditions. So the given conditions are, in triangle ABC, this D, E, F and G are the midpoints of sides BC, AD, BE and CF. So let me write it here. So here we need to prove area of triangle ABC is equal to 8 times the area of triangle EFG. So here we need to do some construction work. So we are joining D and F and D and Z. So this is our construction. So now let's move on the proof. So as we have discussed earlier here, so AD is the median of triangle ABC. So we can say here the area of triangle ABC is equal to twice area of triangle ABD. And here the reason is the median of triangle bisects the triangle into equal halves. So now let's move on next triangle here. You can see, so in this triangle ABD, so if you take AD as a base, and here you can see is the midpoint of AD, so B is the median. So we can say area of triangle ABD is equal to 2 times the area of triangle BED or BDE. So here it also have the same region, so no need to write it twice. So we can just simply write here same as above. So now let's move on to statement 3. So in this triangle BED, if B is the base, then F is the midpoint of B. So here FD is the median. So again the median FD bisects the triangle BED in 2 equal halves. So you can see here triangle BED is equal to 2 times triangle DEF. So here if you combine these all three statements, then you can get here area of triangle ABC is equal to 8 times 2 multiply 2 multiply 2 is 8 times triangle DEF. And here the reason is from statements 1, 2 and 3. So lastly what we need to do is here we need to show these two triangles DEF and triangle EFG are equal in area. So for that, first of all we need to show DZ is parallel to this line B. So you can see here in this triangle BFC, here Z is also midpoint of FC and here D is the midpoint of BC. So here the line segment joining midpoints of any two sides of triangle is parallel to the third side. So by that property we can say this is parallel to BF. Sorry, we have written here B, so it's BF. So the reason is since D and G are the midpoints of sides BC and FC respectively, or you can say here the line segment joining any two sides of triangle is parallel to the third side. That's also okay for here. So now let's move on the next one. So here since the triangles EFD and EFG lie on the same base EF and between same parallel DZ, they will be equal in area. So we are going to write this just now. So here we have written area of triangle EFD is equal to area of triangle EFG because they lie on same base EF and between same parallel EF and DZ. So this is the reason for that. Now, so if you compare these statements 6 and 4 here, in place of triangle DEF you can substitute by the value of triangle EFG. So it's about to be proved. So area of triangle ABC is equal to 8 times area of triangle EFG. So here we can simply say from statements 4 and 6, or we can say here we have just substituted the value. So substitution axiom. So here we have proved it. So this is how we can prove it. So the main thing is don't feel that our theorem is a very hard task. So this is the easiest part of the question, but due to some reasons we feel very difficult. But if we focused on the property that which we are going to use, if you make a good plan here, then certainly you can solve it easily. I hope you enjoyed the video. So let's hope we'll be meeting in the next video for this time. Let's say bye for this time. See you in the next video.